In this lecture, I will talk to you about debris flow monitoring and warning. And I will start with a definition of what a debris flow is. A debris flow can be defined as a type of mass movement that may occur in mountain torrents, suddenly occur in mountain torrents, and it appears as a wave with a steep front consisting mainly of boulders, and it consists of a mixture of very poorly sorted sediments in water that range from boulder size fragments down to clay. And after this steep front, the flow height diminishes until it appears just as muddy water. This is a definition, but then the best way to show what a debris flow is look at one of these phenomena. And I will show you a video now that has been shot in the Gadria Torrent, which is an instrumented catchment located in the Bozen province. And it has been equipped by the Bozen province, Dr. Pierpaolo Macconi. And here we go. This video has been shot last summer in 2013. And I will comment the video so that the definition that I gave can be followed just through the images. This is the torrent. The check dam that you can see in the front ground is more or less 2 meters high. The wings also are 2 meters high, and the width is about 8 meters. So you can appreciate the dimension of this sudden flow that can be, of course, very destructive. Few years ago here in Piedmont, one of these phenomena just swept away a building, a 3-story building, and causing several casualties in Rio Garen, close to Torre Pellice. So this particular instrumented basin is currently under investigation within a European project named CEDALP, and the equipment installed in that basin consists of several different types of device. Which one? Of course, when we talk about monitoring and warning of debris flows, it's not so easy to keep these two fields separate one from each other, because the devices that you use for monitoring are very often the same that you can use as in building warning systems. In any case, I will try in this lecture to keep these two fields separate, starting with the monitoring devices and the monitoring systems that are used for this phenomenon. So let's talk about monitoring devices for debris flows. Here you can see a table that has been published by Japanese researcher back in 2005, Yasumasa Itakura, who is a good friend and worked with us in the Moscardo Torrent several years ago. Is summarized in this table the main devices employed for the monitoring of debris flows. Let's see some of them. Well, of course, rain gauges are widely used to collect the information regarding the rainfalls that can trigger the debris flow itself. Then we have the stage sensors to monitor the stage level in the torrent. There are different types of this. The picture here show what is called an ultrasonic sensor, but then also a radar sensor, or also laser sensor can be used for the same purpose. Then we have the broad family of contact sensors. Here you can see wire sensor. And then we have ground vibration sensors that can be used also for monitoring debris flows. You can see in the picture what is called a seismometer, but then we also have geophones, underground microphones, hydrophones. All here you can see a geophone. all of this family measuring the ground vibration produced by debris flows. We then also have, and they are not mentioned in this list, the pendulums. And in this other table, Itakura summarizes the main parameters that can be monitored and measured through these different types of device. So you see depth, velocity, mean front velocity, discharge, volume, impact pressure, and so on. Itakura also indicates with the different symbols, the different types of parameters that can be measured by the devices. Now let's talk about stage sensors just to start. In this photograph you can see an ultrasonic sensors. We are in the Moscardo torrent here, and the stage sensor can be employed to measure and estimate different types of information. One of these is the velocity, the mean velocity of the front, and this is usually measured using 2 or more stage sensors, ultrasonic sensors placed at a known distance along the torrent, and knowing the distance between the two stations and the time elapsed between the appearance of the front at the first and second sensor, you can estimate the velocity. I was mentioning the front because the typical hydrograph that is measured through a stage sensor appears like this. You can see in this photo, usually the front is very easily recognized in the picture. So you can, in the hydrograph, so you can use that appearance as a feature to measure to determine velocity. Then also impact force can be estimated indirectly, of course, measuring and knowing the velocity. And then finally also the volume. In literature, the volume has been proposed as one of the parameters that can be measured through a stage sensor using that formula and employing the mean velocity of the front as constant velocity along the entire debris flow wave. This particular formula, which gives, of course, a rough estimate, has never been tested in the field. And the Galleria torrent offers a specific and very particular opportunity to estimate, to make an estimation of the goodness of this formula, because right downstream of the video camera that shot the video that I showed you before, there is another video camera that is shooting downstream, and downstream of those installations there is a large deposition basin with a slit check dam that is particularly favorable for estimating and testing the formula that I showed you before for the estimation of the volume. I will now show you a video that has been shot the very same day of the event that I showed you before, and that has been taken with this other video camera shooting downstream. You can see the slit check dam, and this video, which takes is about 35-40 minutes long, has been shortened here just to show you that the most part of the material remains deposited in the basin, in the deposition basin. You will see now several subsequent surges arriving in the images, and you will see that just a little portion of the mixture just flow downstream of the slit. The main part just deposits in the basin. You can see it here. If you follow this arriving surge, you will see that it's practically completely deposited within the basin. This allowed us to make an extraordinary test for comparing the results obtained here is another search.